Exponential functions. Today we're talking compound interest. So in general, interest is usually talking about money, either gaining money or gaining how much money you owe. For instance, you put money in a bank and over time it gains interest, or you borrow money from a bank and over time you have to pay more in interest. So here's the general formula you usually see. Let's go over what each piece means. The A in this formula represents the final amount in the bank account, or the final amount that you owe in the loan. The P is known as the principal, which is just the fancy way of saying the starting amount in the bank account. This 1 is just going to stay a 1. The R is the interest rate itself, and in problems it's usually represented as a percent. The T is time, and that's usually measured in how many years the money has been in the bank account. And the last piece is the N, and that's the compound factor. That's what makes these compound interest problems different from simple interest. Notice that the N shows up in 2 separate spots. Now most of the time they'll give you word problems for compound interest, so the most important thing to know is how to find each of these values within a word problem. Now the N, or the compound factor, is going to be a value that depends on the problem itself. And for that value, we're thinking of how many times is it compounded each year. For instance, if you're looking at a word problem and it says something is compounded daily, what that's saying is every day of the year it gains interest. And so this value for N would be how many times within a year that happens. If it happens every single day, 365 days in a year, then our N would be 365. However, if it said compounded weekly, usually they use the number 52 to say 52 weeks in a year. Next up would be monthly. So if it happened every single month, 1 year later, it would happen 12 times because there are 12 months in a year. If they say compounded quarterly, there are 4 quarters in a dollar, 4 quarters in a whole, so it would happen 4 times in 1 year. They said semi-annually, that's every half of a year, which means it would happen 2 times within a year. And if they said either annually or yearly, it happens once per year. And for almost every word problem, they use the same handful of words. So if you understand this concept or memorize these numbers, they'll show up quite frequently in these types of problems. So how do we use all of this in a word problem? All right, let's say you were given this word problem. First thing is find whichever pieces they've given you already. Here they say she deposited $520, and whatever you start with, that's your P, that's your principal. To help remember, sometimes I say the P is whatever you put into the bank, and that's the same thing as deposit. The next important thing we see is the 3.5% interest rate. A rate percent is our R, and then this is the type of phrase you're looking for these compound interest. Compounded monthly, that's your N, your compound factor. And remember, monthly means 12 times in a year. Now they want to know what will the balance be, what will the final amount be after 2 years, which is our time. So if we write out all our values, the final balance is what we're looking for, so we don't know that one yet. The P is the amount she put in, the 520. The R is that interest rate, which is 3.5%. Now something to know about percents in math. Anytime you're using a percent in an equation, you almost always want to divide it by 100. If you see that symbol, divide it by 100 before you use it in a formula. So if you divide that 3.5 by 100, you end up with 0.035. Again, N is that compounded factor. In this case, compounded monthly means 12. And lastly, we got the T for time, which was 2 years. So if we take these values, plug them into this formula, it should look like this. We can just plug all of this into a calculator, and whatever answer it gives you should be the final amount. However, you may need to be careful typing this in depending on what calculator you're using. If you're using a Desmos calculator, it should look exactly the same as this. Key things to note are that these 2 numbers are in the exponent, and that this 1 plus is not inside of that fraction. When I put this in the calculator, I get $557.647, and that 7 means we should round the 4 up to a 5. And so after 2 years, now the account has $557.65 in it. And if we take away the starting amount, that means Jasmine gained $37.65 in interest. Here we have another word problem. First thing is find which variables they gave you. Alex currently has this much money in his account, which means it's not the starting amount. We're looking at the final amount. And then it says he opened it 6 years ago, so that would be how much time has gone by. Now it says an annual interest rate of 6.8%, so that's going to be our R, our rate. And here it says compounded annually, which means our compound factor is going to be 1. How much money did he use to open the account? How much did he put in? How much did he start with? That's our P. So same as before, if we write out all our values, substitute them into this formula, and then here's what that should look like. And now we have a case where our unknown is not isolated, it's not by itself. So we need to take all this and move it to the other side of the equal sign. And yes, even though this looks very crazy, these parentheses are just saying it's multiplying by that P. So in order for it to move to the other side, it needs to divide. And since this value here is already on this side, when this whole term divides, we're just going to write it underneath in a fraction. And so here's what that should look like after you divided it. If you're allowed to use Desmos, you'll just type it into the calculator to make it look exactly like this. It's 1 times 6 is an exponent. It's 1 plus the fraction inside the parentheses, all on the bottom of the fraction, with our A value being on top. Now, if you're not allowed to use a Desmos calculator, you'll want to use your order of operations on this one. First is parentheses, simplify that fraction. Anything divided by 1 stays the same. So that's the fraction simplified. Add those 2 together. So everything in the parentheses is simplified. Then we go to the exponent. 1 times 6 is just 6. And so at this point, you would still need a calculator anyway. However, now it's a lot less complicated to type in. When I type this in the calculator, I get 1200.017. And again, that 7 would bump the one up to $1,200.02. So this is the amount that Lex first put into the bank account 6 years ago. And after 6 years of gaining interest, it's now at $1,780. So if the question was asking how much did they gain in interest, you would just subtract the final amount after interest and the original amount that they put in the bank account. And the difference between the two would be the amount of interest they gained. Thanks for watching. Please like and subscribe for more videos, and hopefully now these compound interest problems look a little less intimidating.